Hey, the motion has been fixed, so let's talk a little bit about it. I was on the right track there when we were discussing earlier in class, but um, it wasn't quite right. Okay, so let's talk a little bit about what I've done here. You have, I'm going to set this to -1, and that should still work. So what we have is we have this flag um, called the motion. Initially, when I press on the flag, it's -1. The flag is going to be 1 when we move to the right, 0 when we move to the left. And that's because um, righties are better than lefties. Okay. I kid. I'm kidding. My son and my wife are both lefties. Um, I'm a righty. I don't know about my baby boy yet. But to the right is 1, to the left is 0. So here, for example, if you press the right arrow, and if within that, when I press the right arrow, I check the following condition. If I'm not touching the wall, then I can move to the right. And I'm going to set motion to 1. Or if I am touching the wall, but my motion is equal to 0, then I can still move to the right. When would this happen? If you touch the wall and your motion is equal to 0, that means you were moving to the left, because that's motion equal to 0 is when you move to the left. So it's okay to move if you're touching the wall, so long as your motion before was to the left. Then I can move to the right, and I'll set motion back to 1. So the same can be said for moving to the left. If I press the left arrow, then I'll check 2 conditions. If I'm not touching the wall, then I can move to the left. Or if I am touching the wall, but my motion is equal to 1, which means I was moving to the right before I touched the wall, then I can move to the left. So that works here. Let me press start. I'll move to the left. Notice I can't move any further to the left, but then I'm not stuck. I can move to the right. So let me summarize this one more time. There's an if statement within an if statement for both algorithms. Press the right arrow. That means I want to go to the right. If I'm not touching the wall, then I'm okay to move to the right. I will change x by 8, set motion to 1. Again, 1 is to the right, 0 is to the left. Say I press the right arrow and I am touching the wall, just like the spaceship is touching right here. If I am touching the wall, then I do need to check another condition, which is how was I moving to the left when I hit the wall? And that's what this checks. If my motion was to the left, again, left is 0, then I can move to the right. Inversely, the left arrow, when you move to the left, you press the left arrow. If you're not touching the wall, you can move left. Or if you are touching the wall, but your motion was to the right, that means you were moving to the right, right. You hit a wall, okay? And you stopped. Then this variable is 1. I can then move to the left. And this should work. I don't have a boundary on the left, but I can actually fix that really quick. I can take this boundary, move it right there, press the flag, and now if I move to the right, notice it stops and it lets me move. It doesn't let me go past. Now this algorithm should work also for moving up and down if you have boundaries on top and bottom. So take a look at the algorithm. If you have any questions regarding the algorithm, as always, let me know. We can discuss. This is just one way of restricting motion on a boundary where you have a boundary here, which by the wall, the way the wall is a sprite of its own. I hope this helps. Again, just a little more instruction using Scratch, all kinds of different things you can do. Here's one way to restrict the motion based on a boundary.